Today we are going to do something fun. Well, as a software engineer, we just touch our keyboard and the mouse. And I wanted to introduce you to Node-RED, so I thought maybe I should introduce you Node-RED through something more physical, like uh, an ESP32 module. We are going to read some temperature information and then send it through MQTT to Node-RED, and Node-RED is going to be installed on the server. What is Node-RED? I'm going to actually introduce that soon. Let's just skip that part. Yeah, so let's just jump into it. Node-RED, in simple term, is low-code programming for event-driven applications. So that's it. The video is done. We are going to end it here. Well, no, wait. Yeah, so it is pretty self-explanatory. There are some tricks I'm going to describe later as we go in the video. The event-driven applications doesn't mean that it itself is designed to just listen to your events. It is a Node.js based service. It works like a Node.js service, and it actually runs with Node.js. So as a normal Node.js service, C# service, Go service, it has some components. It can listen to, it can make gRPC requests, it can make HTTP requests, it can listen to MQTT topics, it can have WebSocket connections, it can have Redis integrated into it, Kafka integrated into it, but MQTT, WebSockets, HTTP come by default with it. The rest have to be developed for it. You can just simply develop them as a Node.js package, but most of what I said is already there by the community. The community is huge because it is a JavaScript based community. But to give you a boost of an idea of like what you can do, like from this sentence, like from this picture, not even this sentence, just forget about this sentence. From this picture, let me see what I get. Let me tell you what I understand, or what I think I can do with it. The first example that comes into my mind that I can do with this is this. Maybe some of you have been into a situation where you have an area and then you want to do something, check some access mediums, tickets, and so on, and there's no internet for security reasons. Let me give you my own experience. So I was in a company long ago, around like 6 years ago and so on, and we had to sell some tickets and then in that area, and then we had to actually scan them, and then in the area we didn't have internet. So what you do is that to download these into an Excel and then give it to a computer there, and then or like push it to all of the access devices. But it is manual, right? It is like 1990 solution. What we didn't know back then is this picture that I just showed you. So what you can do, for example, with this is that you can have a Raspberry Pi and then you can have Node-RED on it without any coding. It is zero coding. You just need Node, like, no, you have some coding, let's say 90%, not much code, like 10% coding, let's say. But the other is like playing around with the components. We are going to see in the video soon. One Raspberry Pi is going to fetch the tickets from the internet once, perhaps 3 hours before the event starts, and then it's going to distribute it to all of the devices, or all of the devices are going to communicate with this one, and then you can now check with an actual ticket. And now you can also even connect the cashier system and sell tickets here, and then synchronize the sold tickets with your server later. So then you can actually see how many of them were actually sold. So as you see, you can do a lot with just one picture that they have here. It runs pretty smoothly on Raspberry Pi because it's Node.js based. It's very lightweight. The other idea that you can do with it, which is not really obvious here, maybe it is. Let me check. No, it's not. But I mean, based on the description that they had at the top, good for event-driven applications is this. Let's say you have microservice A, you have microservice B. The microservice typical, like the normal issues, right? Microservice A is going to publish a payload. Microservice B has to receive this payload. What you do, either the microservice A has to know how the B is going to receive it, or the B has to know how A is going to send it. But then now you have coupling. So you add it is only for one endpoint. Now let's say that you have 10 endpoints, and then now you have 10 couplings. Let's say each of them have their own payloads. Now what you do is that you get the problem, right? Because I had the headache before for this, because the teams are going to be dependent on each other. There's going to be ongoing hours and hours of discussion of what to do. So instead, what you can do is that to give the responsibility of transforming this data to a third-party service. This third-party service can be Node-RED. So you put Node-RED in the center, and then you're going to send the data from A to Node-RED, and Node-RED will send it to B. So you have like a middleware, let's say. In microservices, this is not really like the monolithic world anymore. A middleware like this can be out of your service, and since the request is internal, it's like your local host on port 8080 is calling another applications on 8081. So you're good. Unless that, yeah, so there can be some discussions that what if my node, one of them is in US, the other one is in Germany. Yeah, but that's another discussion. But it is still pretty fast, because that question can also come, what if microservice B is running in Germany, the other one is running in US, right? That still can come, so that doesn't matter. Now let's say that, for example, with microservice A, you are going to publish an event. Node-RED is going to catch this event and then knows what to do with it. It's going to transform and then make an HTTP request to microservice B. Even maybe a Kafka topic is also there. Node-RED is listening to it and then getting some data from the database as the database changes with Kafka sources, and then use a Kafka sync with HTTP to send it to Node-RED. Node-RED transforms it, either puts it back into Kafka or make a HTTP request somewhere else, or gRPC call somewhere else, and so on. So you get the point, right? It brings the decoupling. Now someone may ask, hey Farhad, why should I do that? I can create my own service and then use that service. Well, yes, you can do that, but if you want to reinvent the wheel, yeah. So in that case, you just go do that. But the point is that Node-RED deployment is a soft deployment. It's not a hard deployment. Even it has versioning, it has revisions. You can source control your flows and so on. But deploying a new change is just pressing a button. You just don't need to do much. Service A has changed. You need to change a property. You just go to Node-RED, change the property, press deploy. And the service B doesn't change at all. So you don't really need to change that much. So your deployment is not monolithic anymore. This is in case that I assume that you already know how to do backward and forward compatibility, because that is a case also without Node-RED. So you have to still be compatible. So if service A goes up, Node-RED should not crash. Node-RED should still work, but you just go there. So if, let's say this, if you don't do Node-RED and you have the backward-forward compatibility in mind, service B will have deprecated information, and then you may become lazy. You will not become lazy. You will actually don't want to change the code base, because it's hard to do that, and it has a lot of process unit tests to be checked. So you will procrastinate it, and this deprecated endpoint will never become deprecated. It's always going to be there inside the service A's code base, because the service B's code base is hard to touch. So Node-RED is there, and you put it there. You just simply go on and then change it, and then remove it completely from service A in the next release. Problem solved, right? Well, it's not a silver bullet to everything, but I guess you get the idea. Well, with that, let's just jump into Node-RED and see it in action. Okay, now let me show you how you can install it locally, and then later we are going to check how we can install it on an environment like Kubernetes. Well, just come to the documentations, getting started, and here you have a couple of options. And what we care about right now in this video is running it locally and in Docker. For running it locally, you just simply say npm ig node. That's it.
A few moments later.
After it is installed, so for me it was already there, but one quick tip for the Windows users. make sure that you do it as an administrator. Just open your PowerShell or your command line as an admin and then run the npm ig node-red. Believe me, it's going to make your life easier, but maybe it's changed right now. Run it once without. If it didn't work, don't panic. It's just running with admin and then you're good to go. So now that I have it, how do I use it? So just run node-red, just as simple as that, and then come to it. So by default, it's running on 88 on port 8080. And as you see, I have a bunch of stuff running here. So it is my test environment. But let's go on and add a new flow. I want to show you the components it has. As you see, there are some built-in components it has. This one is not from, this is I created myself. This is a subflow. Later we can go through it more if you want to. This is basically a flow inside a flow. So this is called a flow. A flow basically, let's say, consider it's not like a normal let's say controller. I would say, like, consider it like a plain.cs file, like C# or Go file, that you can put everything in there. Your endpoints, logics, and so on are in there. So that's basically it. And then when you deploy, all of the flows are going to start running, and then you can actually switch between the flows. For example, you can, in one flow, you can listen to MQTT and then handle MQTT messages, and the handling of the MQTT messages is going to be on a handler flow. Let's say, like, you see the idea, you have a controller and the controller have an endpoint. The endpoint will call a handler. The handler will do some database calls, which the database calls can be another flow, and so on. But I'm gonna show you how the request is going to look like. What I'm interested to show you here is a simple HTTP call. So first, let me get the HTTP request out. One side is the input, this is the input, and this is the output. This is whatever comes out. Some of them only have one side, this means this only has output, and some of them has only input, which is this one. Just gets into it, it does something, and that's it, right? So let's remove it. Let me say something that you will use a lot in Node-RED is inject. One of the components that you use a lot is the inject node. It's this one. The other one is the debug node. Yeah, so now what I want to do is this. I want to make a HTTP call here. So let me fake JSON payload. Let's get this one, and let's just get this. And each of them has their own properties. If I come here, this one has its own. What inject does basically is for testing or starting something. For example, you have a job running with an interval, but sometimes you want to do it manually. You just open Node-RED, and then I will show you how to do the inject. And then you just say what you want to inject. Here it says I want to inject the payload, and the payload is of type the millisecond science. So this is right now, like the Linux timestamp. And then you can have a JSON and so on. You can even change this. But for now, the focus is here. So let me go on and then set this URL. As you see, it has its own. It is a GET request. And then I can also enable a bunch of other stuff. And the debug is pretty simple. The debug says what you want to put into the debug console. I am in the debug console. It's up here. And then I say, okay, I want to log the payload. It's basically like console.log, right? And then now everything is there. Let me do this. So as you see, this is the trigger button. I have the JSON string. It is not the JSON object. This is the JSON string from this request. Now, what else you can do? So everything which is here is changeable. How? I can come here and say, oh, I want to make the URL dynamic. So I want to push the URL. So let me remove it from here and not put it here. So let's actually set this back to payload. See what happens if I remove that right now. Get back. It says no URL specifier. Oh, great. So now let me come back here and then specify the URL for it. The type of my variable is a string, and then I'm going to deploy again. and inject. As you see, I just get the response back again. Now on the other side also, everything that comes, let me actually show you the full object. So you can come here and say, okay, I want a complete MSG object. By the way, the MSG object is the global object for your flow. Not what I call the flow is a bit different. So the flow for me is like the flow of the request that comes, like all of these lines which are connected together. So if I now show the message for you, there's an ID to this message, and there's the URL that we set in the inject, and the topic which is set to empty. Here you can just remove it also, and then if you do this again, there's no topic anymore. And then there are the headers, the response URL, everything that you have after this HTTP request you can read here. Now what I want is to manipulate this, so I will just add a function, and you can do a lot of stuff. So besides this, you can have other things too. For example, you have switch, right? The switch, what this switch does is that you get one input, get multiple outputs. It's basically a switch. You can add different checks, and then, for example, you can say, if it is this, then go to the channel 1, 2, 3, and 4, and then you will get them, and then you can send them out, right? This is also amazing. And then the other thing that I want to show you right now is that one thing that is really nice in Node.js is that it's JavaScript based. So I can come here and say, oh, the user ID that I am getting from this payload, I want to keep. So I'm just going to parse the JSON string and then get the user ID. And then I'm going to replace the payload with, I don't know, foo bar, and done. Now let me show you what will happen. So this, I don't want the whole thing, I want the payload. Why do I do that? I'm gonna show you very soon. Here, now I can just read the user ID. Well, in Node-RED, it is important to know that this payload, the payload in the message object, is important because Node-RED uses it a lot. Every component uses the payload. For example, even the switch, you can, like by default, if I open it, it says from the payload, what do you want to change? So for example, you say, no, from the payload user ID, I want to check this. Everything comes through the payload. But for the switch, it's also a little bit different. You can also check a flow, you can check the global and so on, which I'm going to go through soon too. But the important note is that you should remember that as long as these lines are connected together up to the end point, this is the start, this is the end, this is the start, this is the end, and then the payload may get manipulated by different components. Some parts of this payload I may need to keep. For example, I made a request, there's a user ID in it, the user ID is going to be used in another request, another call, but perhaps inside the header and so on. So what you need to know is that this message is basically a scoped object for this whole request until it becomes a response. And in this case, my request is triggered by this inject. We are just going to trigger it with something else soon. But for now, you need to know that this MSG can be manipulated by you. Consider it like the window context in the browser. And then now I can inject. It is going to, of course, fail me. Yes, so I have a typo here. This is user ID capital I. Let's remove. And as you see, I have this here. Now I can actually pass this ID until my request is going to go on. What do I mean with that? Let's say that here I have actually, I have to trigger this. Actually, we have to make a change. We want to trigger this not with inject, but an HTTP request. So we want to make an HTTP request. And then with that HTTP request, we are going to trigger. So let me come here and then make this, let's make it the post request and then call it API test. And then msg.url, because here, as you saw here, the URL was set by this inject, but we are not having that inject anymore. So I'm going to just use a function to make this URL. And what else we can also do is that now, if I do a debug, I can read the payload also from here. So let me go on and then make a post request here. Yeah, that's one is already there. So as you see, I also just, if I call it, I just ran it again, and I do not have any body right now, but let me add a JSON body here. Just make it JSON bar foo, and I have the object from the debug 8. You can just click it. Also, it just shows you which one is doing the login for you. And then but one issue is here that now it is actually going and going and going, and it's not really showing me, like, it is not really stopping. It's the request is stuck. Why? Because it's a simple request. The request needs a response. You have to respond back. So to respond back, I'm just going to add an HTTP response, and I'm just going to connect it here. And then now let's come back and make the request again. As you see, I got the response back with the payload that I changed. So I have changed the payload here. I got the bar foo. The payload now is set to something else. Now I receive it here. So it's important to know that in the whole of these lines connected to each other, even if they are not visible. What do I mean with that? If you are using a link in and a link out. So if I am using this, and here just say this, and then debug 9, and let me disable all of these ones. So this is not really showing that they are connected unless you click, right? So this is now says, okay, this is connected. You will use this if, for example, you want to jump between different flows, or you want to, or your flow is too big and you want, for example, because you can have a really big flow, and then you want to jump around. So let me now run this again. As you see, I get the debug 9 has jumped here. As long as I am in this link, then MSG is going to have everything that I need. Let me actually show you the full object. And if so I have the user ID, right? This is the point. This is what I wanted to show you, because, and you should not be scared of changing this, because it is scoped to this one specific request. So you can change it as long as you know what is your logic. And if another request comes in, it has its own MSG object and it has its own state. One thing to know and take care is that if you are running on an IoT device, like you're running on Raspberry Pi, and then you are controlling the hardware itself, you're controlling it for a drone, or you have some LED states and so on, go on and then set the global state. What you have here is that you can say global and then set, for example, I don't know, device state to online, for example, let's say. Right? You certainly can do that on an IoT. Do not do this when you are using this in Kubernetes as a normal Node.js service. It is a normal Node.js service. It is not different than a Node.js service that you have created with Express.js, with routes, controllers, and so on. And you should not keep static variables in your code. Why? Because if you have two replicas, then this state is inconsistent. Either keep it in Redis, so you can come in manage palettes. So in install, just search for Redis and install it. I think I already installed one. Yep, this one is already installed, for example. Let me show you. For example, you come here, say Redis out, just give your Redis configuration to it, just configure Redis here, and then save your state in Redis, so it's in a shared environment. It's like a very, I just want to make sure that I make the point that this is just a Node.js service. This is just a simple API-based service that you can use, and with extra steps and components. Yeah, so with this, I think there's nothing else I just want to show you right now. Yeah, so these are, I will put for you to go and check out. There are some WebSocket connections and so on you can configure. Right now I have my own, no, it's not on this one, the one that is on Kubernetes is configured. But you can do like you can do TCP calls, you can do UDP calls, you can do gRPC, but this gRPC is not. So one thing about the gRPC in Node-RED is that the gRPC doesn't do the bidirectional streaming, it just do request streaming. So you can do streaming from your request, and then you can close the connection and then get your response back as just one single object, no streaming back. So the streaming back in Node-RED is not there, but you can implement it yourself if really needed. But yeah, let's just jump into a little bit more practical example. We are in VS Code. I have the platform IO extension installed on VS Code, and what I want to show, this project actually does a lot more than just the BME 2080. If you have seen the video about the AI and Jarvis, this is the one which does the microphone controls, the speaker controls, and beside that I was also using the BME 280. So let me show you something like quickly. If you are interested later, I can also go through this to show you how you can, for example, connect with Wi-Fi, because here I am connecting to my home Wi-Fi, how you can do configuration with different ESP32s, different Wi-Fi's and so on without pushing the configuration to your source control and things like that. Let me know if you're interested. We are going to take care of that. But for now, let me go through this. So I first have a Wi-Fi class. I connect to Wi-Fi inside my main function. As you see, this is the first thing I do. This is the Wi-Fi connection, and then after I am connected to the Wi-Fi, I'm gonna create a new instance of my device, introduce the device, because I am on MQTT. I have to name my device and give it an ID. So these two are hard-coded, not hard-coded inside the code, but coming from a configuration. And then I have my MQTT. I send the device to the MQTT, and then also will pass the MQTT server with the configuration. This is my MQTT server. It is running on my home cluster. If I go to this MQTT, what it has inside the class, it has publish and it has subscribe and so on. Now, if I go back here, I also create a new instance of the BME 2080 class, and then I pass the MQTT class of mine to it. Why? Because now inside the BME, I'm going to read the temperature and read the humidity. And then after reading it, I'm going to report it. So this means that, or inside the report, I'm going to read it. So I have a throttle. I'm going to report this in a certain interval. In my case, it's every minute. And then after the interval is hit, I'm going to read the information and publish to MQTT. Now, what does it mean for us? For Node-RED, it means that we have to listen to a topic for temperature and humidity. But how is this topic built in our MQTT is coming where I have get topic here. Let me go on and find this. So the get topic is that I'm calling all of my devices Tiba, and then after that I have the device name, device ID, and the suffix. So if I come back to my Node-RED and I add an MQTT in, and then I just simply say I want to listen to Tiba, anything after it doesn't matter, and then I say debug and then deploy. Maybe I have to oh, this is actually disconnected. Let me connect it also. Okay, yeah, these are the microphone information that is coming back we got the maybe I have to disconnect the microphone. Let me disconnect the microphone and then try this again.
One eternity later.
The reason that we are seeing all of these, I just remembered, is my other flow. It's this one. So I have to shut these down. So this is sending back the state. I'm not interested. This can be removed. And this is the audio one. That's the problematic one. So let's do this. I want to bring this back and turn this off. Nice and easy.
More moments later.
Okay, so I think I know what the problem is. This will not really work right now because I am consuming the information somewhere else. So if I come here and then do this and then reset, I should get the information. Yeah, so the device, it's just gonna say online and so on. So if I now come here and connect it to this or this, as you see what I'm doing here, this is actually the node which is running on my home cluster. So what is happening here is listening to the temperature and humidity. After it comes, it's going to parse the topic. It's going to get the device name, device ID out of it. As you see, after 30 seconds right now, it is giving me the information about the temperature and the humidity. What will happen is that it is then going to check the status and then it's going to update the device. I have a device database, and this is the case if you have multiple of these devices at home. And then you can insert the logs of these inside the database. And also you can publicly, right now, immediately publish this in through a WebSocket. And this WebSocket connection is actually connected to a Raspberry Pi project, which I did in this video. I'm going to share the link. And then it is listening to the Raspberry Pi, to the WebSocket, and then it shows the humidity and the temperature live to the user on the touch screen that it has. Yeah, so this actually is running here right now. Let me delete this. As you see, again, the flow is pretty simple. You don't really need to do that much here. Let me also, this also going to show you the status of how everything was saved. This also, so this is another example I have for you to actually know what you can do with Node-RED. This endpoint here that I have, this API node device logs aggregate, what it does is that there is a Kubernetes, let me show you, there is a Kubernetes cron job running for me, and it is calling this endpoint for me to do certain things. This endpoint eventually will go to a Go service, and the Go service will just archive all of my temperature and humidity logs during the day, and then just create an average. Says, okay, 12 hours, in the past 12 hours, the humidity and the temperature has been like this, and now it starts the next 12 hours. So this is here. So let me come to Node first. And this is the device like aggregator. I have this cron job, and I have two actually. One is for day, and then one for is for the night. Let me actually describe it here. Can I open the job? Just the job itself. Yeah. So what it does, simply as you see, it's going to curl and then just call Node-RED on the same cluster. It is the internal endpoint, and then it is going to follow whatever we saw in Node-RED itself. So this API node device logs and so on is exactly what is here. And now if I come here, I can actually show you Node-RED running. So it is running only on one replica, and it is simply, does it have a restart? No. it is running for 4 months and it is doing a lot, but it has no restart. So this is like it is getting 30 seconds in every 30 seconds calls, but it's not that much calls. But I'm planning actually to use it for much more. If you have more devices, you will have more requests and so on. But as you see, this just does what I need, and you can do a lot with it. For example, to some scale, you can have some flow for validation, some flow for transformation, and so on. But I guess it's enough about Node-RED itself. I'm going to show you how you can bring it to Kubernetes. Installing Node-RED on Kubernetes actually is no-brainer. It's pretty simple. It's as simple as how you install it locally. There's one point that I want to point out to you. Actually, there are 2 points. One is that there is no official Helm chart from Node-RED team. You can create one yourself, or you can use the one that I use. It's pretty safe. There is not any risk to it. Rather than make sure to keep the image updated. Like if there is a Node-RED issue, as a security issue, make sure you give the image yourself to the chart and not use the existing one, because maybe the chart is not updated and so on. The second point is what I'm going to show you right now. So if I show you my Helm values, I have something called persistence true. And someone may ask, why do you have persistence in Node-RED? The reason is all of these flows and so on are stored somewhere, right? Everything is stored somewhere. And if I don't enable persistence and I restart the pod, which can happen in Kubernetes, you will have the whole flow, everything lost. So that's, I don't want to happen. So if I come to the pod itself, I see that there is a volume called data loaded under the path/data. If I search for this, let me see if I can actually find this. Yes. So as you see, this is using a PVC. The PVC is called Node-RED. The PVC is created automatically as soon as you enable the persistent in the Helm chart, and then the volumes called data will be loaded into the data path. Now let's see what is under that path. If I come here, this path is not inside this pod, is mounted into it. And it has all of the Node-RED configuration, including our flows, including the node modules that the Node-RED needs. Basically a whole Node.js service is running here. I guess even if I do Node, yeah, so even Node is running here. So it's basically a Node.js service. This is what is important to have in mind when you are installing Node-RED, to make sure you have a volume attached to it. Now the Helm chart that I use is this Node-RED Helm. It's from Schwartz IT. And now if I get into it, so yeah, so this is the one that I use. It's pretty safe. They are having yeah, so everything is, maybe it says 5 months ago and so on, but you can always go to the chart itself. Like, let me get to the template and the deployment. I guess the image, yeah, so this is the image registry and so on, and the tag, you can configure it yourself. So you can just say which tag of the Node-RED image you want, but this is for the sidecar, of course. Let me also find the, yeah, so this is the other one. It says values image.tag. You can of course change this and then have it all up to date. So this is basically a very generic Helm chart built for you, and you don't really need to do it yourself. Here we go again with another video. Thank you that you watched to this point. I hope I have inspired you enough, because the point was to get you a new perspective, looking at the problem perhaps from another point, right? So to see, okay, I have this, now let's try something new from now on and see how it's gonna improve my work life, personal life, my hobby projects, and so on. So if you like this video, make sure you add the thumb up. If you didn't, add the thumb down, it's fine, but let me know why so I can improve. If you have any questions, don't hesitate to just write it in the comment section. We are going to check it out together. And if you're not a subscriber interested into similar contents like this, make sure to hit that subscribe button. And with all that, see you on the next one. Cheers.